Okay, today we're going to do greatest common factor. You will see it as GCF, greatest common factor. Do not get greatest common factor confused with least common multiple. They are two different things, okay? So we're going to do two ways of doing the greatest common factor. So we're going to do the first way. So this is 22b3. The one thing that I can tell you, the tip that I can give you for greatest common factor is to look at these two numbers and ask yourself, what is the biggest number I can reduce them both by? Think of this like it was a fraction, and if I could reduce 10 and 20, what is the largest, the greatest number I can reduce by? Yes, I can reduce them both by 2. Yes, I can reduce them both by 5. But the largest thing I can reduce them both by is 10. Now I'm going to go through the motions this way, this first way, to show you how the greatest common factor will be 10. So the first thing we're going to do is 10. We're going to list off the factors of 10. Factor means two numbers multiplied together that give you 10. Okay? So 1 times 10 gives you 10. Okay? So the way that I do it, just to make it simple, is I'll start with 1. 1 times 10. Now let's go to 2. 2 times, is there 2 times something that gives you 10? Yes. 2 times 5. 2 and 5. 3, no, that doesn't divide into 10. 4, 5, now we're back to 5. So that's all the factors. But the way that I normally list them, I list them in order. I don't list them all unorganized like this. So I'm going to show you the way that I list them. I'll start with 1, and then I scoot over and put 10. Because this is going to be the smallest number, that's the largest number. Then I'll put 2, and then I'll put a comma and scoot over and put 5. Well, then that's it. So, and I just leave it like this with this space in between. No big deal. Okay? So now let's list the factors of 20. What are two numbers we can multiply together to get 20? Well, start with 1. 1 and 20. Now, 2, yeah, 2 and 10. 3, no. 4, yes. 4 and 5. Now these two numbers are close together. I've squeezed the gap in of going through all the numbers, because 6, no. 7, no. 8, no. 9, now we're back to 10. So that's it. So the book is also going to want you to, after you've listed the factors, you need to circle all the ones they have in common. Well, because that's the whole point of greatest common factor. They have 1 in common, they have 2 in common, they have 5 in common, and they have 10 in common. Now the greatest, the largest number they have in common is 10. And that's what I had said previously, is what is the largest number I could reduce both of them by. Alright, now let's go to 22b number 2, 16 and 32. Again, you still have to show your work, but you can think in your brain, what's the largest number I can reduce them both by. Okay, but we're going to write down the factors. Two numbers multiplied together to give you 16. 1 and 16. 2, yes. 2 and 8. 3, no. 3 times nothing gives you 16. 4, yes. 4 times 4, and you don't have to list it twice. Since we got to 4 times 4, once you've gotten to where you've got the same number or two numbers close together, you've gotten all the factors. I mean, if you want to go back through, 5, no, that doesn't divide into 16. 6, no. 7, no. Now we're back to 8. That's how you know when you can stop. Okay, let's do 32. 1 times 32. 2 times 16. 3 times nothing. 4 times 8. 5 times, no. 6, no. 7, no. Now we're at 8. So now you circle all the ones they have in common. They have 2 in common, 4 in common, 8 in common, and 16 in common. So the largest number, the greatest common factor, is 16. If I was going to reduce both of those, I could reduce both of them by 16. So that is one way you can find the greatest common factor, is by listing off all the factors and find the largest number they have in common. Okay? The second way you can find this, the greatest common factor, which is normally what I will do, because you could be working with fairly large numbers, and you're used to doing this with least common multiple, so you might as well just do it this way for greatest common factor. So looking at 22b12, we're going to find the greatest common factor for 36 and 48, and we're going to start off by making a factor tree like we did with least common multiple, because we're going to find the prime factors. So 36, we can break it down into 6, 6. 6 can be broken down into 2 and 3, 2 and 3. So those are the prime factors. So I'm going to write down here 36. The prime factors for 36 are 2 times 3 times 2 times 3. I'm just listing the prime factors. Now let's do a factor tree for 48. We can break that down into 6 and 8. 6 can be broken down into 2 and 3. 8 can be broken down into 4 and 2. 4 can still be broken down into 2 and 2. Okay, now we're down to the prime numbers. You need to list all your prime numbers at the bottom of the branches. So that'd be 2 times 3 times 2 times 2 times 2. Everything at the bottom of the branches. 2 times 3 times 2 times 2 times 2. There was 1, 2, 3, 4 2s and 1 3. 1, 2, 3, 4 2s and 1 3. You always want to make sure you get everything. To find the greatest common factor, you take only the numbers they have in common. Okay, so if you need to circle them, they have a 2 in common, they have a 3 in common, they have this 2 in common, and that's it. These are extras. So the ones that they have in common, you take those numbers only one time. So I'm going to take the 2 that they have in common once, 2 times. The 3 they have in common, 3 times the 2 they have in common, 2, and that's it. You only take what they have in common one time, then multiply those numbers together. 2 times 3 is 6, 6 times 2, 12. So your greatest common factor for 36 and 48 is 12. In other words, if I could reduce both of those, reducing both of those numbers, the largest number I could reduce by is 12 if it was a fraction. Okay, look at 22b, number 13. We're going to do the greatest common factor of 66 and 90. So in the second way, you start out by making a factor tree because we want to list the prime factors of each number. So 66, I can break that down into 6 and 11. I can continue breaking down 6 into 2 and 3. Now I'm at prime numbers. I can't break 11 down anymore. So the prime numbers for 66 are 2 times 3 times 11. Okay? Now let's get the prime factors for 90. So 90, I can break that down into 9 and 10. Well, I can keep breaking 9 into 3 times 3, and I can keep breaking down 10 into 5 times 2. All of those are prime factors. I can't break them down anymore. So the prime factors of 90 are 3 times 3 times 5 times 2. Make sure you get all the numbers at the bottom of your branches. Okay? Now what you do is you look at what they have in common. They have a 3 in common, and they actually have this 2 in common right there. And then nothing else is in common. So to find the greatest common factor, you multiply only the ones they have in common, and you take that number one time. They have 3 in common, you take it once. They have the 2 in common, you take it once. So 3 times 2 is 6. So your greatest common factor, if you are going to reduce that as a fraction, the largest number you could reduce both of them by is 6.